A power series can be differentiated or integrated term by term over an interval contained entirely within its interval of convergence. So generally speaking, you need to do the work to find the interval of convergence in the first place. In the case of differentiation, we're not doing differentiation for this, but you need an open interval. So what you would do for our integral, if you want to integrate a power series, you just can integrate term by term, and you can just rewrite the series as a series of the integrals, and you integrate with respect to x. But remember, it's only valid if the interval over which you're integrating is contained within the interval of convergence. So for our example here, we're going to find the integral from 0 to 1 of the series from n equals 0 to infinity minus 3 to the n times x to the n over the square root of n plus 1, all of that with respect to x. Right, so if this wasn't something we'd already done, we would be looking at that series and we would be applying the ratio test, finding the interval of convergence, and then we would be seeing if this interval from 0 to 0.1 is within there. But you may remember, I'm just going to show you very, very briefly anyway, we have actually already found the interval of convergence for that. So for this particular sequence, I'll just browse through it. We did the ratio test, simplified everything, realized that the series converged when the absolute value of x was less than 1/3. So we found the radius of convergence, and then we considered the endpoints. So when the ratio test equals 1, which would be when x was minus 1/3 or 1/3, we realized that the series was a p-series with p equals 0.5 when x was minus 1/3, so it didn't converge then. But when x was 1/3, we had an alternating series which passed the alternating series test. So it did converge when x was 1/3. So in conclusion, the interval of convergence for this particular series is x is greater than minus 1/3, and it's less than or equal to 1/3. If you want more on that, then please seek out that particular video. Right, so now we know that this particular interval from 0 to 0.1 is completely contained within the interval from minus 1/3 to 1/3. From 0 to 0.1, x, remember it can be those, that lies within interval of convergence. Which we know we just said was minus 1/3, x 1/3. So the integral from x equals 0 to 0.1 of this particular series, so the series from n equals 0 to infinity of minus 3 to the n x to the n over the square root of n plus 1 dx, that's going to be equal to the series of the integrals. So that's going to be equal to the sum from n equals 0 to infinity. What we're going to do here, we're going to integrate with respect to x. So we're going to have minus 3 to the n. Remember, n isn't relevant, but we are now going to have to integrate the x term. So that is going to be x to the n plus 1 over n plus 1. So x to the n plus 1 over, we better have an n plus 1. And then we have a square root n plus 1 already there. And remember this, we're evaluating this at 0.1 and at 0. So just integrate as you would normally. So we could have probably done this a line ago, but we're going to pull out everything that isn't dependent on x. So I'm going to say this is the sum from n equals 0 to infinity of, well, we're going to say minus 3 to the n over, well, you've got n plus 1 times the square root of n plus 1. So that's like n plus 1 to the power 1 times n plus 1 to the power 0.5. Remember this, so this is, you could write that as n plus 1 to the power 3 over 2. So over n plus 1 to the power 3 over 2. So all of that, now we can do the integral part, which would be x to the power n plus 1, evaluated at 0.1 and 0. So it would be 0.1 to the power n plus 1 minus 0 to the power n plus 1. So conveniently, the 0 to the power n plus 1 just disappears. So we just have this 0.1 to the power n plus 1. So now the final result of the integral can be expressed as the sum from n equals 0 to infinity of, well, you've got minus 3 to the n times 0.1 to the power n plus 1 all over n plus 1 to the 3 over 2. And that n plus 1 to the 3 over 2, it doesn't necessarily look better than n plus 1 times the square root n plus 1, but I decided to express it like that on this occasion.